This video involves subtracting rational expressions. Now, if you followed what you were doing with adding rational expressions, the idea of subtracting rational expressions, everything's exactly the same. The only thing that you have to be very careful of is remember that you are subtracting the numerator of the second fraction now. All right, so let's jump right into examples here. For example, in this first one, I noticed that I have an LCD of 12. Now I'm going to rewrite it as m to the third n. I always like things in alphabetical order. Restriction again would be m cannot equal 0, n cannot equal 0. All right, I have my LCD. Now I notice that both of these denominators are identical. So that means we have common denominators. And all I have to do is combine my numerators. Now, I'm going to make a suggestion. It's up to you as to whether to follow it or not. But this is something I always do for subtraction. I write down my first numerator. I have 1m minus 6n. And then I am subtracting the second numerator. So I'm going to take negative 1 times m minus 5n. I'm going to rewrite this just so I see it. 1m minus 6n minus 1m plus 5n. And oftentimes right here is where people will end up making mistakes. They'll forget that they have to subtract both parts there. So if I combine my like terms here, let's see, the m's cancel out, and I'm left with negative 1n. I take that numerator, I bring in the LCD, and I'm left with negative 1n over 12m cubed n. All right, so I look at this and I say to myself, now wait a minute. I still can simplify because I have a monomial divided by a monomial. I notice that the n's are going to cancel out here. So my final answer would be negative 1 over 12m cubed. But remember, we still have the restrictions that m cannot equal 0. And yes, n cannot equal 0. Even though it canceled out, we still include it as part of the restriction. All right, so take a look at this next one here. I again have a common denominator, but I notice that both of these denominators can be factored to n times p minus 1. And that leads me to my LCD of 9 times p minus 1. All right, that gives me a restriction that p cannot equal 1. All right, because I have common denominators, don't have to do anything, don't have to play the game with the numerators. But I'm subtracting, so I want to be careful here. I have 1p plus 4. And then I, again, like to write negative 1 and distribute that to the p minus 5 so I don't mess up any signs. All right, so this would be 1p plus 4 minus 1p plus 5. When I combine like terms, I get 9. All right, I take that over. I bring the numerator, 9, together with the denominator, 9 times p minus 1. And I notice again, things can cancel. So when I simplify this, I have 1 over p minus 1 with the restriction that p cannot equal 1. All right, so how do I do it when I have uncommon denominators? Again, the process doesn't change, okay? The thing that I have to be cautious of, which is already built in to the what's given, what's missing statement or part of the problem, I have to remember instead of writing a plus, I write a minus. All right, so here we go. From this first one, I notice I have uncommon denominators. I know that my LCD here between the numbers 5 and 6 would be 30. And between the variables x, I know it would be x to the third. My restriction will be x cannot equal 0. I play the game. I'm given 4. I look at 5x. I compare it to 30x cubed. I know I am missing a 6. 5 times 6 would give me the 30. and I'm missing an x squared. X times x squared would give me the x to the third. Now I write down the second given minus 3y. Notice there's that subtraction. And then I look at 6x cubed and see what's missing there. And I know I'm missing a 5, and that's it. I clean this up. 24x squared minus 15y. I notice from these that I have a GCF of 3. So I pull that out. I'm left with 8x squared minus 5y. And that's as simplified as I can make the numerator. I put them together. 3 times x squared minus 5y divided by 30x cubed. All right, I notice that the 3 and the 30 can simplify. So 3 and 30, leaving me with a 10 down in the denominator. My end result would be 8x squared minus 5y divided by 10 with the restriction that x cannot equal 0. All right, a few more examples to go through here just to make sure that we've covered all our bases. In this one, I've got an LCD here from binomials of m plus 6 and m minus 6. So that gives me a restriction that m cannot equal plus or minus 6. Play the game. I'm given 4m. In the first fraction, I'm missing m minus 6. Second fraction, I'm given minus 6. From m minus 6, I know I'm missing m plus 6. Again, what's missing comes from comparing the given denominator to the LCD. All right, so this simplifies to 4m squared minus 24m minus 6m minus 36. Combine like terms, I get 4m squared minus 30m minus 36. I recognize I have a GCF. I'm going to take care of that first. M squared minus 10m minus 12. So let's think here. Any factors of 12, negative 12, that would add to give me negative 10. So I'm thinking 1 and 12, nope. It'll be 1 and negative 12, sorry. 2 and negative 6, nope. 3 and negative 4, nope. There it is. That's as simplified as I can go. My end result would be 3 times m squared minus 10m minus 12 divided by m plus 6 times m minus 6 with a restriction of m cannot equal plus or minus 6. Okay, looking at the next problem. All right, let's see here. I've got an LCD of m minus 4 and m minus 6. Play the game. 4 times m minus 6 minus 4 times m minus 4. I've got 4m minus 24 minus 4m plus 16, and that simplifies to negative 8. Looks good to me. All right. So now I rewrite this as negative 8 divided by m minus 4 times m minus 6 with a restriction. Oh, forgot that at the beginning, didn't I? M cannot equal 4 and 6. So there's my restriction again. M cannot equal 4 or 6. All right, and my last problem here. I notice in the second denominator, I've got a GCF of 3. So this will break down to x squared minus 3x minus 10. Ooh, and I noticed that that trinomial can also be factored. So this denominator is really 3 times x minus 5 times x plus 2. All right. LCD, 3 from the monomials, x minus 5 and x plus 2. Restrictions, x cannot equal 5 and negative 2. Okie dokie. Step 2, play the game. So I've got 6x. Let's see, I have to multiply that times x minus 5 and x plus 2. And then I have minus 3x, and from that denominator, I'm not missing anything, so I'm going to multiply it by 1. All right, so let's see here. I'm going to make this 6x squared minus 30x by distributing that 6x into the first one. And then I'm going to FOIL. So I've got 6x cubed plus 12x squared minus 30x squared minus 60x minus 3x. Woo, lots of work on this one. So I've got 6x cubed. Combine my x squareds, that would be minus 18x squared. Combine my x's, that would be minus 63x. All right, I notice that I have a GCF here of, I'm thinking 6x, but 6 won't work with the 63. So let's drop it down to 3x. Let's see what happens there. I've got 2x squared minus 6x minus 21. I'm wondering if this can factor any further. Let me just check it. I've got negative 42 for the goal number, negative 6. So first thought would be 2 and negative 21. Nope. How about 3? Does 3 go in? Let's see. That'd be negative 14. Oh, we're getting closer, but that's negative 11. 4 doesn't go in, 5 doesn't go in. How about 6? And negative 7, that'd be negative 1. Okay, so that tells me it can't be factored. So now I come over and I'm going to put everything together. I've got 3x times 2x squared minus 6x minus 21. Bring in the LCD, 3 times x minus 5 times x plus 2. I can cancel the 3's, and I'm left with x times 2x squared minus 6x minus 21 divided by x minus 5 times x plus 2, with the restriction that x cannot equal 5 and negative 2. All right. Hope this is all good for you. Good luck. Let me know if you have any questions.